for a single color pixel, how much frequency it has. That's what in the frequency domain it will say. So when I'm changing the one pixel, that means one coefficient information in the sense, for that particular color information, over the entire image, I'm changing. So it will not be dot 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 kind of thing. Instead of that, it will be somewhat filtered or smoothed or somewhat blurred. Okay. So whenever we do any transformation function, if we lose some information of single bit or a minimal number of bit, after we inverse transform, definitely the image will get blurred. That's what, without adding any watermark or without doing any operation, if you are transforming an image and again if you are inverse transforming it, the original image and the transform image will not have the same PSMR. It will have the differ. Okay. So that means the quality of the original image and the inverse transform image, definitely it will get changed. The reason, the normal non-integer based transformation when we do, based on the decimal location, something we have to remove it. So after removing, the remaining only we will consider as a whole number and we will multiply and we will try to bring it back. So during that time, definitely we will not have the same value. Maybe initially 5.3 will be there, but now maybe 5.2 or 5.4 or 5.299, something like that, or even 5.1, something like that it will be there. So in the, because of that, we will have a degradation in the image only for the transformation. But in the integer based transformation, in case if you are not leaving any decimal point, okay, this error will not happen. The reason, non-integer based transformation, your coefficient, it not has a fixed number of digits. It is a floating value with infinite number of decimal locations. But in an integer based, your number or coefficient is fixed integer, single digit, and when you transform or inverse transform, the divided by whatever is there, again it will be in the 2 power. So maximum whatever is there in the binary, the 2 power shift after the decimal location, it will be stay. So when we do the inverse transform back, definitely we will get the same values. So integer based transforms, it will be somewhat better for the watermarking kind of thing. Can you repeat the question? Securing, in case of secure, you are asking. Secured means time domain is not at all secured, ma'am. It's blind eyes we can able to check. So directly if you read the, what is the decimal values you have, you can directly see. So with that particular position, what is the bit it has? What is a particular bit, we can easily read it. Even the normal image itself, there some dot dot will be there now. Easily we can know, definitely something is changed in that page. So only that particular pixel location I can read it. So I can find out only with the 8-bit 256 combination alone will be there. Some 4 combination I check, that is more than sufficient to check. But in frequency domain, it's not like that. So in frequency domain, if you change anything, after coming to time domain, in the time domain, the variation is throughout the image. So that too, it's not a fixed position throughout the image. So the image will get smoothed. So we can't sure where exactly it will be. Even we go for the frequency domain, definitely we can't understand. It's not an image or something. So that frequency values, whenever a transform image we see, we'll look, that means a corner pixel or a center pixel points, remaining everything as a black or white kind of. So with that we can understand what actually it is. So that is our thing. So the invisible watermark in the transform domain, whenever I added some pixels, or sorry, it's not a pixel, whenever I added some values in the sense, I'm actually affecting the entire image value. So after affecting the entire image value, one location if I change, I'm affecting the entire image. But I said I'm going to divide the image as 64 pixels of sub images. So 640 into 480 in the sense 4800 different blocks will be there. So each block 1 bit I'm changing. So throughout the image 4800 bits I'm changing. So for the entire image, the frequency domain, I'm not changing single bit, I'm changing 4800 bit. But someplace maybe the bit, changing bit and the actual bit will be same. So worst case possibility, 4800 positions or 4800 bits actually I'm changing. So definitely my quality of the image will be degraded. But the effect, whatever the change I'm doing, it will be for black by black based. So it's not for the entire throughout 640 into 480. Instead of that, it is only for the 64. For the 64 pixel, what is the change I am going to do? Only that will reflect. So it will not degrade much quality for the entire image. So the last one is watermark extraction. This is not done in the hardware. This is for the other thing. Once, because in camera itself we no need to extract it. We just capture the image, we'll embed the watermark, we'll store it as a video or image, as a JPEG format or something, image format. So at last, this source file will take it to some other medium. There we have to extract the watermark. So the extraction of watermark is required how we embed the watermark bits in the image. So without knowing this, definitely it will be difficult to extract it. So for this, we use some simple algorithm, but it's somewhat effective, we understood. So what we did in the sense, once we transform the image or block of size, so blocks of pixels into a transform domain, first stage, that means we have two stages of transformation. First 1D transform and then 2D transform. So the first 1D transform, whatever we did, that first 1D transform, first 8 pixels, second 8 pixels, third 8 pixels, or something like that. User can define a bit location, that means a pixel location initially. So that pixel location, something like user after he purchased, when he initialized camera, he can fix it. I can fix for the location of 0, or I can fix for the location of 3, or I can fix the location of 7, something like that. You can fix the location. So once user fix the location, after a transform happen, that particular pixel location, that means 0 in case out of 63, I fixed 34 as my location in the sense. So this fifth frame, when I process, this 34 will be the third coefficient actually. So when I process the fifth frame, third coefficient is the 34th pixel. So that 34th pixel, 34th coefficient, whatever I am getting, in that the first MSB 6-bit we are going to take. That MSB 6-bit, it will say the address for the second stage watermark location. It means after the first stage transformation, during the second stage Hadamard transform, in that particular location, because this location is not defined by the user. This is randomly generated, purely random, based on the image. In the image, only 34th location I fixed. But 34th location, what is the pixel value is there, we don't know. And what kind of coefficient it will generate, we don't know. So with that coefficient, it will say the 6-bit value. That 6-bit value will say the location for the second stage transformation. So in the second stage transformation, when that particular, that means in case if this 34 location is saying something 40, in the second stage transformation, this 40 means 1, 2, 3, 4, 5, 6. Sixth frame when I process, whatever the first coefficient is there, in that first coefficient, I need to embed my watermark. So it's completely random, no one knows. So this is based on each and every user, it's different. So whenever you purchase your device, you can keep your location. So each and every person will keep different thing, and each and every image it will be different. So each and every image, again it will be different. After that, in the second stage, the 40th coefficient, which bit you have to change, that will also defined by the user. So the user has to say 34th location and bit position of 2, 3, 4, something like that. So which bit position you are changing, that in that particular location, the particular bit location will get changed. But it's better to change the lower nibble address instead of higher nibble, because higher nibble if you are changing, the frequency component will change much higher. But lower nibble, if you are changing, will be very low. So inside the lower nibble, any bit location you can able to give. That is the restriction we give. So here I said the watermark bit has only one bit and the bit position is 3 and the bit location, sorry, pixel location is 0. So whenever the first stage Hadamard transform finished, in the 0th location, first frame 0th location, whatever the coefficient is there, that coefficient first 6 bit will say one address. That address will used for the second stage Hadamard transform coefficient, and that bit position will embed the watermark. So this is a watermarking algorithm. So this is completely based on the mux because only if else condition. So which location I have to check. So if 0th location is there, read the data. If first location is there, read the data. This design is completely based on the mux. So this is not a mathematical. That's what I said, it's a combination of things. Previous Hadamard transform, everything based on max we create. Yeah, previous Hadamard transform and other things we created based on the mathematical functionality and we created the hardware. But here it's completely a logical functionality. So that's what we said, the system is completely based on hybrid, both mathematical and logical. So now this original, that means the actual system what we are going to build. So any doubts in the watermarking or something? So till now whatever we comprise, from that the system